In this video, we're going to look at integration by substitution, but this time with involving limits. So let's take this example. So we've got x times x plus 1 all cubed integrated dx between the limits of 2 and 0. But what I'm going to do is to accentuate this fact that it's x equals 2 because it's an x variable. When we do integration by substitution, we're going to go to a u variable. So let's make a substitution and say let u be x plus 1. So du by dx will be 1, and then therefore du is the same thing as dx. So we need to change or make a substitution for x. Well, we can do that by saying u is x plus 1, therefore x is the same as u minus 1. So I'm going to make a little substitution section again, as we did in previous videos. So let's do that in pink here. So substitution, so we're absolutely lucid about what happens. So we're going to say that x plus 1 cubed is the same as u cubed, and then we can say that x will be substituted with u minus 1, and therefore dx will be substituted with du. But we're not finished. What we can't do is then use the limits of x of 2 and 0. That will be incorrect. So in an integration by substitution question, we need to change the limits. So you make it explicit to the examiner, make it very vivid, and say the change of limits, and we show what that is. So we say when x equals 2, we can say u is x plus 1, which is 2 plus 1. So the new limit is now 3. So we're going to do the same thing when x equals 0. So we're going to say when x equals 0, u equals x plus 1. So that's going to be 0 plus 1, which is 1. So now we can do it as substitution. So as before, we're going to write the old integral out so we can see what we're doing. So it's the integral originally between x equals 2 and x equals 0. And then you've got x times x plus 1 raised to the power of 3 dx. But we need to substitute this in terms of u. So we can now say our new limits are now u equals 3, u equals 1, and then we could say, well, x now becomes, going back to our substitution section, u minus 1 is x. So we can say, we can replace x with u minus 1. We said that x plus 1 all cubed is u cubed, so we could write that down here, u cubed, and therefore dx is exactly the same as du. So now again we get a very simple integral. That's the whole point of integration by substitution. So our limits are 3 and 1. So we get u to the power 4 minus u cubed du, and that will give me the following here: 1 over 5 u to the power 5 minus 1 over 4 u to the power 4. And then you got 3 and 1. And let's substitute these values in. So we get a fifth times 3 to the power 5 minus a quarter 3 to the power 4 minus, substituting 1 here, and then we can just type this straight into our calculator to get the result required. So if we type that straight into our calculator, we got a fifth times 3 to the power of 5 minus a quarter times 3 to the power of 4 minus a fifth minus a quarter in brackets, right? And that gives me 142 over 5. I mean, I always prefer a fraction as opposed to a decimal. Okay, so the last example is the integral of cos x times the square root of 1 plus sine x with the limits of pi over 2 and 0. Don't forget they're in terms of x, not u. So do we have a function in this derivative? Yes, we do. So we're going to say let u be 1 plus sine x. And then we could say that du by dx, the differentiation of 1 is 0, differentiation of sine x is cos x. So du is cos x dx. So what we can do now is say, let's write a substitution section. And say, well, cos x dx is going to be substituted with du. The square root of 1 plus sine x is the same thing as 1 plus sine x raised to the power of a half, which will be the same thing as u to the power of a half. But again, we cannot use incorrect limits, so we need to change the limits. So change of limits. But what's that? When x is pi over 2, we can say u is 1 plus sine pi over 2. That's 1 plus 1, which will be 2. And now we're going to do the same when x equals 0. So when x equals 0, we're going to get u is 1 plus sine of 0. That's 1 plus 0, which is 1. So now our integrand now becomes that I now becomes the integral of, if we go back to our question, so the square root of 1 plus sine x is going to get replaced with u to the power of a half, and cos x gets replaced with du. So we're going to get u to the power of a half du, but now the new limits of u equals 2 and u equals 1. So now when we integrate that now, we're going to get u to the power 3 over 2 divided by 3 over 2 between the limits of 2 and 1. And that will work out to be 2/3 u to the power 3 over 2, 2 and 1. And then we can evaluate that. So it's 2/3, I'm going to take the constant out, u to the power 3 over 2 between 2 and 1. Well, that's the same thing as the following. So we can say that 2/3, so we get 2/3, 2 to the power 3 over 2 minus 1 to the power 3 over 2. Well, this is the same thing as the following. 2/3 times 2 to the power of a half raised to the power of 3 from the laws of indices, and that's just minus 1. Well, we know that 2 to the power of a half is the square root of 2, and we're doing it to the power of 3, so it's 2 to the power of a half raised to the power of 3 is root 2 times root 2 times root 2, which will give me 2 root 2. So now we could write our final solution as the following. 2/3 times 2 root 2 minus 1 as our final solution.